Hello and welcome to my video, lesson 1.2 on composition of functions. So basically, this lesson is all about a function within a function, which we can write in two different ways. You have to be able to recognize both. The one that I just boxed is the one that I prefer. It's the one that helps me understand what's going on. The underlined one, it means the same thing, it's just differently written. Fog is kind of what it looks like. F of G, that F is gone there from the of. But the boxed one makes a lot of sense because basically we're working just like normal, using like kind of bedmass rules, where inside the brackets here and here you can see that we have to do that G of X first. So this happens first, whatever's inside the brackets here. And if you do that, then you get the result. Then you can put it inside of f of x as the x. Okay, so here we have the functions, and I tried to color coordinate them so you can follow along. So the red one is the g of x, the blue one is the f of x. And we're going to pick some quote-unquote nice values for x. So one of them that we're going to use is going to be -2. And if we use, oh no, that's not going to work actually because we need to be on a corner. That almost worked. -3 almost works as well. Ooh, it's actually not going to be very nice here, but we can just use this point. We'll just use the 1 point, which is a 0. And what value for g of x do we get? We get the 2. And so based off of that 2, we can then plug that into our f of x function. And so this is really f of 2 is what we're looking at. And so the result would be where 2 is for the f function. So it's going to be up here, which is at 5. So what this means, and I know this is written kind of strangely, but what this means is f of g of 0 equals 5. Or another way of saying that is f of g of 0 equals 5. Okay, and I know I put extra blanks there, but we're just going to use the 1 value for this question. Okay, so using the same graph, we're going to go ahead and try it a little differently. We're going to try to do g of f of x. So we're going to flip this around, and so I'm going to actually purposely change this. Okay, so like I said, we purposely wanted to change the order a little bit here. So what we're going to do now is try to find different values for f of x using different values of x. So originally, let's use a -2, -1, 0, 1, and +2. So -2 gives us +5. -1 gives us -1. 0 gives us -3. Back to -1. Back to +5. So when we plug this into our g function, it's g of 5, g of -1, g of -3, g of -1, g of 5. And we'll see how easily we can actually draw these. It depends on how they line up. So g of 5 lines up right here. So that gives us a value of 3. The next one, -1, gives us a value of, ooh, and that's kind of hard to see there, but I'm going to say like -1.75. roughly. -3 gives us 1. That's going to be the same, -0.75 and 3. Okay, so when we actually draw this, actually the values don't end up where you think they are. So 5, this is the -1, this is the 1.75. Not -1.75, just +1.75. But if we were to draw this out, again, the combination is g of f of -2 equals 3, right? So it's actually of these values back here. So -2 is our x value, and then we have 3. -1 is our x value, and we have -1.75. 0 is our x value, we have 1, -1 or +1.75, and then 2 gives us the 3. So those values there that we can see, those 5 values in green, are the ones that we just found. Okay, and the kind of cool thing is we can actually graph these if we knew the actual values here, but we don't actually know these functions. We could figure them out, but we're not going to graph them in this case. We'll go ahead and do that on a future question. Okay, so you could be, just by the way, you could be asked to do the exact same thing as the above if you're given a table of values. It's the same process. Okay, so here we have a couple different questions. G of f of 2. So how do we evaluate this? Well, we first do the f of 2. So we go g of 4 times 2, which is g of 8, which we can then put in as 8 squared minus 3. So 64 minus 3, so 61. I suggest that you pause the video now and try out the rest of these questions yourself. Okay, so this one would be h of, and then g of -3. So -3 in brackets squared minus 3, which simplifies to h of 9 minus 3 is 6, which then goes to 2 times 6, so 12. All right, again, you can pause the video now. So this is f of h. So what we're going to do is f of, and then we'll get the h value. So it's 2 times 7. So that means it's f of 14. And so it's 4 times 14, which is 28. All right, so again, you can just plug in the values if you have equations, but making sure that you're doing in the correct order. But now what we're going to do is try to actually find the algebraic functions of all 3 of these, doing basically the same sort of steps. F of g of x, well, what we're going to do is we're going to have f of, and then g of x is x squared minus 3. So that part in brackets is going to go instead of my x in the f function, which means that we're going to have 4 times, and then this is instead of x, which means that we can write it like this, and then we can graph using the vars feature. Now, this is a bit of a weird one when we're graphing with the vars, but what we're going to do is we're going to put in 4x here. We're going to put in x squared minus 3 here. And when we graph this, we want to compare it to what we think we have. to verify. So this is what we think is the function within a function. And so when we graph it, that pink one is what we think it's going to be. But if we want to make this work using vars, what we can do is the f function we can write as 4x, but instead of x, you're going to go vars, and you're going to put in the g function, because it's f of g. So instead of it being an x, you're using y2. And so that green one completely overlaps the pink one, as you can see with the table of values as well, which means that it's verified, that this is correct. That's what that means. Okay, pause the video now and see if you can get the same result as me for B and C. Okay, so this is h of f of x. So it's going to be h of, and then we can get f of x, which is 4x. And then when we put the 4x into the h function, it's 2 times 4x, which means it simplifies to 8x. This one is the simplest example of them all. We could go ahead and graph it as well to verify, but I think you'll take my word for it. This next one is g of h of x, so we're going to write g of h of x, which is 2x. Now we're going to put in the 2x inside the g function. So instead of the x, we're putting in 2x. So again, this is instead of the x in the g function. So when we simplify this, it becomes 4x squared minus 3. And that looks pretty good, but let's go ahead and actually check this one. So there is our g function. So I'll make this one my h function. This is 4x minus, it should be 3. And this should be y1, which is my h of x, squared minus 3. And you can see again the pink and the green overlapped completely, as you can see from the table of values as well. And so that's how we know we did it correctly. All right, I hope this video helped you better understand the idea of a function within a function, these idea of composite functions, and good luck.